Okay, now we're entering values from frequency distribution tables into our calculator. We did this earlier with mean. It's exactly the same way. So on some so we want to find the mean and the standard deviation from a table of like values like this, frequency distribution table. So we go 16 STO to M plus. Now with some people it's not M plus. I believe you press the data button or the change button. All right, 17 STO 0 M plus. Notice we're actually putting no 17s in there. On some calculators, it will say data set 1 for the first one. Enter the first data set, it'll say data set 1. For some calculators, when you enter the second bit of data, because there are no 17s, it'll still say data set 1, but I believe some people's calculators will also say data set 2. So don't worry if it says data set 1 or 2. On the older calculators, I think it still says data set 1 because 17 has 0 frequency. You're really entering nothing. Got it? And then when you enter the next one, it should say data set 2 then for some calcs, but others will say data set 3. Okay? Now, once you enter all those, you're then doing your recall X bar for your mean and your recall sigma X. Have we got some answers for those? What have we got? 17 point, oh, that's a bit low. It's not that. Mean is 19.76. Now, girls, this means the score 16 occurred twice. There are no 17s. There are 3 18s, 8 19s. If these were your results in a test, your average is going to be between the highest and the lowest and the highest scores. So 19.76 looks like a good average, and a few people got that answer. Calculator, the ELW532XH. You use these two buttons over here, not the green buttons, to enter your data in a table. So we will go, so I'm just going to clear that stats mode. So second function clear. So we're going 16, this XY button, and then 2, data set 1, and your screen will look like this, 16, 2 data. Then we come back and we press 17, the XY comma, this one, 0 data. And because I actually entered nothing, it still says data set 1 because I entered 0 17s. Next one, 18, the XY comma here, 3 data. It's telling me data set 2, which is true because there were no 17s. I've really only entered 2 lots of data. If I did a recall N at this very minute, how many frequencies so far? Anyone? No? No? 5 so far if I did recall N. I'm doing that now, and I've got 5 frequencies. So it all looks good. I'll keep going. 19, so I'm going back to 19, XY, 8, data set 3. Okay, 20, XY, 10, data set 4. Okay, then we're going 21, XY, 6, data, and 22, XY, 4, data. Data set 6, recall, so I've just pressed recall N. It's telling me I've got 33 scores. If you add up all the frequencies, that is 33. That looks good. Then we're going to go recall X bar. It's telling me that the mean is 19.76. That's what we got before using the other calculator. And the standard deviation recall number 6, 1.48 for standard deviation. Now, for the Sharp EL532WH, the new calculators, you enter your data like this, 16 XY to that data button. It's got the change on it. Then it's 17 XY 0 that data button. 18, XY, 3. That data button with change. You'll enter the next one. Does anyone have any results for that? I need 2 or 3 people with the same answer. Yep, 6.1 or 6.09 is fine. And standard deviation? I'll go, 1.57, okay? Or 6.09 is fine. Now with these girls, that's just individual data, 10, 11, 13. It's going to be a real pain to enter. Do that one at home. Same with the next one. Not very much fun, but tell me how to enter this dot plot into the calculator. Would you do it as individual numbers, or what would you do? Wouldn't you go 0, STO, 2, M plus? Or for the people with the sharp EL, whatever it is, you would go 0, XY, 2, data. Got it? Then you would go 1, STO, 3, M plus for the blue calculator people. Or you would go 1, XY, 3, data. Okay? So please don't enter information in a dot plot, data in a dot plot individually. Don't go and enter the number 4 6 times, etc. It's like a frequency, a dot plot is like a frequency distribution table. Okay? So you'll end up with a mean and standard deviation for those as well. The next page, because you can enter that data yourself at home. We're going to look at these 2 data sets. Tell me what the range is for each. 9, good. Now, let's draw the dot plot. It asks you to draw the dot plot. Go off and draw the dot plots for each. So you do them yourselves. I'm doing it here. I'm going to do a dot plot here as well. Girls, both of these distributions are symmetrical, because if I put a line down the middle, I would get, if I'm looking out, the pattern is symmetrical from the middle. But where do you think, I don't know why I put these individual dots here, but it doesn't matter. You know how I was talking about what standard deviation was, spread from the mean? I want you to work out the mean for each of these. So put the numbers into your calculator, because we have to work out standard deviation. I want a mean and standard deviation for each of those data sets, please. But which one do you think is going to have the biggest standard deviation? Which one do you think is more spread out?
Set 2.
Yes, set 2 should. So can you please enter these for set 1 and set 2? I want a mean and standard deviation. So we notice the mean and the range are identical for both data sets, but the standard deviation is higher for the second set. If I look at where the mean is, which is here, that's where the mean is. Isn't the first set of data, I know there are these 2-bit dots here, but most of the data is around the mean. But here, none of the data is around the mean. It's really spread away from the mean. The definition of standard deviation, the bigger the standard deviation, the further the scores are away from the mean. They're more spread out from the mean. This makes sense that we get a higher standard deviation for this second set of scores. First set of scores, smaller standard deviation. In which data set are the scores more spread out from the mean? It's set 2. And which data set has the largest standard deviation? Set 2. In conclusion, the larger the standard deviation, the what? The more spread out the scores are from the mean. Deviation, deviates, moves away from. That's what deviates means. All right? And the smaller the standard deviation, the more clustered the scores are about the mean. So, another question here. Ladies, before we do any calculations, we're going to try and see if we know which one's got the biggest standard deviation. Do you think they're all symmetrical? They are. If I put a line down the middle, I've done these on purpose. What do you think the mean for this one's going to be? 5. It is 5. This one will be as well. So will this one. But when we do enter these enter all this into the calculator, I'm going to get you to confirm that the means are all 5. But which of these measures are not the same? The mean will be the same. Girls, if I worked out the median, the middle score's definitely in this column. This would be the middle, and this would be the middle. They're the same. What about the range? Same. Interquartile range. It will be the same. The standard deviation will be different. Which one will have the largest standard deviation? Girls, set 1, 2, or 3. I'll call this set 1, 2, or 3. So largest standard deviation is set 3. The smallest, girls, will the smallest be set 1 or 2? Set 1. Now, just looking at these, we're predicting this has the largest standard deviation. Set 1's got the smallest. We think it's set 2's in the middle. Now, and we think that all the means are the same. So now you're going to enter this data into your calculator. For the first set, we would go 2 STO, 2 M plus, etc. 3 STO, 5 M plus, and so on. Or 2 XY, comma, X, comma, Y, 2 data. 3 X, comma, Y, 5 data. Right, I need a mean and standard deviation for each graph. Maybe you can do one, your friends can do one. Now, to work out the interquartile range, whether it would be the same or not, I'm going to see how many scores we've got. We've got 4, 14, and a 16, that's 30. There's 40 scores. There is 40 scores in this data set. 7, 15, there's 15 here, that's 30, there's 40 scores. Remember, interquartile range, I would put 20 to the left, 20 to the right. Isn't that right? For the median, 10, 10, 10, 10. All right. Interquartile range for the first one, let's count 10 numbers. We've got 2 and 7. Q1 is definitely 4. And counting back 10 from here, I've got 2, 7, 8, 9, 10. It would lie in here. Q3 is 6. Interquartile range for this first one is 2. Right. The next data set, how many columns? 1, 2, 3, 4, 5, 6, 7. 7 times 7, 49 bits of data. Splitting it in half, I've got 24, 24, and 1. Splitting these in half, I've got 12 and 12, 12 and 12. I'm going to count 12. Oh, I think they're a bit different. So, sorry. Quartile range for this one, I think if the columns were a bit shorter, if they were 6 high, I think we'd get the same interquartile range. But they're not 6 high, they're 7 high. So 49 scores, 12 scores back, it would lie in here, and this one's in there. Sorry, the IQR for this is 4. So it is different. Sorry about that. The IQR for this, we've got 20 and 16, that's 36, 46, 49. Girls, I think we were meant to have 49 scores for all of them, but this one was different. I think this set's not quite right. And I would break them up the same as before. 12 is here. The 12th coming backwards is here. This has got an interquartile range of 7 minus 3, which is also 4. The problem with the first data set was supposed to be written is that the reason we're getting a slightly, this first graph here's got a different interquartile range. It's got a different number of scores. It's got 40. So either I'd have to top them up a bit to make 49 and balance out the columns a bit. But look, it was meant to be the same. It's just that there's not enough data there. So
you have to add 1 on each.
Yep.
The second one's 2, and the last one's 2.28.
Did anyone also do the means? Okay, so the last one, as predicted, had the largest standard deviation. So please, for homework, you go to Hot Maths, exercise 4E, you will find the widget that goes with this. And the last page as well.